Well, everybody, welcome back to Spring 1. And we're about to have a great talk on Spring Boot Revisited with KoFu and JaFu. This is one of the ones I earmarked and put in a checkbox I wanted to attend, and thankfully I was the MC for it. So, folks, get ready to learn and have a great time. Audrey and Sébastien will be leading, and folks, why don't y'all take it off?
Thanks for the intro. Hi, everybody. Today, we are going to talk about Spring Boot Revisited with KoFu and JaFu, and we are going to explain later what are the strange words. I'm Sébastien Deleuze. I work at VMware as a Spring Framework committer. I'm also responsible for the Kotlin support across the various Spring project, and I work on native applications these days. Could you present yourself, Audrey?
Yeah, for sure. So hello, everyone. My name is Audrey. I'm working for VMware too in the Reactor team, and I'm also contributing on the SpringFu project.
Okay, so you can see at the bottom, you have the address of the Spring One Slack with channel name. So if you want to discuss about what we say here, feel free to join. This is just a standard statement saying that basically we are going to present things that could change because that's ongoing work by the R&D team. So here is today's agenda. So I'm going to present a little bit the context. Then Audrey will talk about the latest evolution of Kotlin and Java and why those languages are interesting for functional programming. I will present what is SpringFu, why we created it, and what are KoFu and JaFu. We will make a zoom on native applications. Audrey will show a demonstration of the famous pet clinic with the KoFu version, and then I will talk about the roadmap. So let's talk about the context a little bit. So enterprise JVM languages have evolved a lot. There is Kotlin, who has been used a lot on Android these days, and usage is increasing on server side. Kotlin is a nice language for functional programming, but it is also a great language that can fit with the enterprise ecosystem, like with Spring. On Java side, I think Java, maybe pushed by Kotlin, has been evolved a lot, and with Java 17, which is the upcoming LTS available next year, I think we will have a pretty nice language that is also suitable for more programmatic constructs, and Audrey will share more about that later. The other context is that there is an hidden gem in Spring Framework since 5.0. It's functional bin registration. It's a way to register your bins using lambdas instead of annotations, and that's not really used yet that much, but it's going to be quite interesting to see how much we can go with that new thing.
So why Kotlin? Well, as you probably already know, if you're attending this session, Kotlin is the last skin in turn of JVM languages, but it already have a huge adoption, especially due to the fact, obviously, that it's officially supported by Android since 2017. But still, compared to other JVM languages, the adoption curves continues to grow over the time, which is a pretty good signal for the future of the language. Obviously, compared to Java, the adoption seems to be minor, but in fact, if we're looking at the number, it's already very impressive, and we're seeing more and more backend projects, either in startup or big companies, starting in Kotlin directly, or even migrating to it, which combined to the continuously growing adoption curve indicate that the language is here to stay. One of the huge advantages of Kotlin compared to Java is that it improves the signal to noise ratio. In Kotlin, you can express ideas, concepts, algorithm in a very clear way, which is extremely important both for maintainability, but also for readability on your day-to-day life of developer. To take just one example, if you want to represent a very simple Pojo, you're just going to declare a data class. And with data class, you will have constructor and parameters declared at the same time. You will be able to specify default values. You will have getters, setters, toString, hashcode, equals methods automatically generated, which removes a lot of boilerplate, and it's immutable by default. A second advantage is the safety, and more especially null safety. Kotlin has turned Java's $1 billion mistake into a powerful feature that has allowed it to deal with the absence of value. So Kotlin checks nullability at compile time, which A, protects you from mistakenly operating on the nullable types, and B, throws compile exception instead of runtime exception if you're trying to access it. You can obviously still declare a value as potentially null, of course, but then using what's called safe calls, you will still be protected by the language against the null pointer exception. Third, discoverability. Like a lot of developers, Sébastien and I are not very passionate when we're having a new toy to play with, and we don't want to spend hours reading the documentation, learning about conventions and all the stuff you need to know before having fun. Hopefully for us, Kotlin is a very intuitive language that allows you to explore it easily with discoverable APIs. Another very interesting aspect of Kotlin is that it allows us to share code and knowledge between different platforms thanks to its multi-platform capabilities. So for example, you will be able to share between the server and the mobile, both for Android and iOS, thanks to the native compiler, and between the server and the front end, thanks to the Kotlin JS compiler. And last but not least, pleasure. It's not because we're coding for work that we don't need to enjoy what we're doing. Writing in Kotlin is a very pleasurable experience, and it's also a very good way to start with functional programming when you're coming from the Java/object world, as the learning curve is very smooth. So now talking about Kotlin support in Spring. A lot of Spring developers love Kotlin and believe in its potential, and that's the reason why we brought a first-class support for the language since more than a year now. So first of all, when you're going to start.spring.io, you can choose whether you want your project to be written in Java or in Kotlin, and then you will be able to use the Kotlin DSL for Gradle, which means that all your favorite tools and languages are available. Then if you're looking at the Spring Framework reference documentation, you will notice that we have translated samples from Java to Kotlin, which means that each code sample is provided in both languages. You just have to switch tabs to see both versions. And it's not just Java translated into Kotlin, it's pure idiomatic Kotlin. And that will also help you on your path on learning the language. We plan to do the same for Reactor boot documentation. We're always looking for contributors. So if you'd like to work on that, please feel free to reach out. And finally, in the guide sections of the website, you will also find a dedicated tutorial written by Sébastien, which will guide you into building a web application from end to end. And obviously, the source code is available on GitHub. So now talking about the support currently existing in Spring Framework, since Spring Framework 5, we provide Kotlin extensions for purely idiomatic API. We provide null safety for 100% of the Spring Framework API, which guarantees perfect integration of the framework in your Kotlin project. We support immutable classes, which means that you don't have to change the way you're coding in Kotlin. You can still use your data class. We have several DSLs available in Kotlin for one of three of the most important APIs, the Bean API, Web API, and Security one. And we support coroutines, which is the way of getting reactive in Kotlin. Now, what's coming up in Spring Framework 5.3 will pursue the effort by adding the support of serialization, the support of Kotlin 1.4, which is the latest version, which has been released mid-August. And we will improve the Kotlin documentation by using Docker 1.4, which is the next version of the language, of the documentation tool. But the good news is that on the other side of the JVM-based language world, Java has not said its last word. Far from that. It has evolved very quickly and very impressively for the last few years. And since the introduction of lambdas in Java 8, new features for functional programming have been added in almost every version. one of the most important features to us is the introduction of records, which have been released as first preview in Java 14 and second preview in Java 15, and which are completely equivalent to Kotlin data classes. So it means that we finally, in Java, have a way to simply declare a pojo and to remove all the boilerplates we used to have, plus we get immutable values. And that's not all, because switch expressions have been refined in Java 13 to be used both as a statement or an expression. That is done with the goal, to be ready for pattern matching in future versions. Pattern matching on its side is already supported for instance of since Java 14. And Java 15, the latest version, brought us sealed classes, which are completely similar to Kotlin sealed classes. So for those of you who are not familiar with that, sealed classes are a set of classes which are allowed to inherit from a parent one. And that is a big step towards a real pattern matching in Java. Other really important projects are on the table for the long term. Project Loom is probably the most famous and most expected one. It will bring fibers, which are lighter threads. It will bring continuations, which are the equivalent of coroutines in Kotlin. Tail calls elimination, but that will be for future version. And Project Panama on its side is working on the interconnection between the JVM and native code. And some of the features, like for example, refi generics, are at the moment on incubation into Project Valhalla.
Okay, thanks, Audrey. So we are now going to talk about what is the SpringFu project. So SpringFu is basically an incubator for a different flavor of Spring Boot. It's a functional programming flavor that is using DSL, so that's advanced API, very specifically tailored for a specific usage, and here it's to configure your application. So in SpringFu, we provide two DSL for the two languages we have described previously. So we have KoFu for Kotlin functional DSL and JaFu for Java functional DSL. And these two DSLs provide the same scope, the same configuration capabilities, but with a syntax that is adapted to each language. So before seeing some code samples, we are going to describe what is the same than regular Spring Boot application and also what changed. So what is the same when you are developing an application with Spring Boot and JaFu or KoFu than your regular annotation-based Spring Boot application? You still are using start.spring.io to start a new project. That does not change. It is based on the Spring Boot, the same Spring Boot infrastructure. So while you will see the configuration API will be pretty different, we are on the shoulder of a giant, and we are just leveraging the same infrastructure than regular Spring Boots, including the various updates that come each month. That's still the Spring configuration for the JVM ecosystem, just a different way of doing it. We still have dependency management, so you will declare your Maven or Gradle dependency without specifying the version, and Spring Boot is in charge to manage the default version of the platform. You still have starters, you will have actuator. We don't support it yet, but the plan is that you will still have your default actuators with the endpoint by default, etc. And you still keep the standalone executable jar or the container deployment model. But what changes? What changes is that in regular Spring Boot application, you have some conventions. For example, you have this application.properties or .yaml file that is at a specific place, and that's a convention. This file is named like that, and if you have some profiles, you are writing application-foo.properties, etc. So this is what I call convention. And you have also automatic configuration. So the configuration of Spring Boot for the whole ecosystem is triggered by various conditions. For example, it can be triggered because there is a specific class in the class path. That's how the Jackson support, for example, is enabled. It can be triggered because there is a specific bin that you declared or that you do not declare. Some configuration could be triggered because you define a specific property. So Spring Boot configuration is full of conditions that are designed by the Spring Boot team to fit with what most people like. And when you have 99% of the people that like this automatic configuration, that's fine. And honestly, the Spring Boot team is doing an amazing job defining this default behavior. But when you have some configuration that are more controversial, like 60% of people like, for example, this kind of behavior and 40% the other, it's more difficult, and that's where a problem begins. Also, it's sometimes hard to understand how that works. That's why sometimes people talk about Spring Boot magic. So so SpringFu is providing a different model. We don't do better because it's honestly not possible. We just do it differently by explicitly declaring the configuration. In Spring Boot regular flavor, it's your configuration and your controllers and your services are annotation-based. In SpringFu, we are going to use functional configuration, lambdas, and method references. In terms of infrastructure, so the low-level infrastructure, in Spring Boot side, you have some reflection, while on SpringFu side, you have a lambda-based infrastructure. And Spring Boot regular flavor is obviously production ready. This is the most used JVM framework in the world. SpringFu, we are in incubating mode. We have not the same level of polish, of scope, so we don't pretend being at the level of the regular Spring Boot. It's an incubating project still. So we are going to see 4 code examples. The first one is Spring Boot regular Java application configured with annotation. So this is the most classical application. You have your main methods with Spring application.run. You have an annotation-based controller specifying 2 endpoints, and that's it. That's really the most simple Spring Boot web application you can imagine with Spring MVC. Now we see the Kotlin version of the same programming model based on annotation. So you have the same building blocks. It's just that you have less boilerplate. The main method does not have to be inside a class artificially. You can see at the right that when you have a very simple method, you can use this short method with equals as a one-liner. But you see the same structure. It's basically the same, and both are easily readable, and both are perfectly fine. You just choose the language you prefer. Now we are going to see the JaFu variant of this application. So JaFu is a functional way to configure your application with Java. Previously, I was hesitating about JaFu because it's more verbose than Kotlin. We will see the Kotlin example just after. So I was hesitating, but after seeing the Java progress and what will be available in Java 17, even if I prefer the KoFu variant, we commit to provide exactly the same scope for JaFu and KoFu, and here is the JaFu version. So you see we are using this kind of Fluent API. We declare web application. We are using classes like that, or we can use lambdas to declare beans. And we have some DSLs to declare web MVC, declare a router. We specify that we have get mapping on those endpoints that refer to the handler. At the right, you can see the handler that has methods that are pure function with a server request input and a server's response return value. And we provide an API to specify that you return an OK HTTP response and the body. Like I said, SpringFu and JaFu and KoFu are about explicit configurations. So it's not enough to have Jackson in the class path. You are declaring at the left the Jackson converter and the string one. And the good thing is that you will not enable the default ones that you will maybe not use. So only what you use is really chipped and only consume memory. So let's now check about the KoFu flavor. So you can see that's exactly the same principle, but with a much more readable code, because really Kotlin is designed for this kind of DSL, and I guess you can easily see it. So we are still declaring our beans. We are declaring web MVC, which is Spring MVC with our router, the same converters. But here you can see that while on the annotation side, it was really a matter of preference between Kotlin and Java. With the DSL, Kotlin has a good advantage in terms of readability, but really, again, both JaFu and KoFu flavor will be supported, and we are working on both in parallel. So what is the current scope of SpringFu 0.4.0 that will be released this week? So on the website, we have support for Spring MVC and Stream Webflux server, support for cores, for web client, which is our reactive web client, including so the Webflux and the web client support includes support for coroutines. We support Jackson, the various converters, Teamleaf, and Mustache. On the Spring Data side, you can use GDBC support of Spring, or you can use R2DBC, which is a reactive way to use SQL databases. You have also support for NoSQL databases like Redis, Cassandra, or MongoDB. And you have some common APIs like logging, beans, and listeners. In terms of efficiency on JVM, we see that the application with the KoFu or the JaFu variant start faster and consume less memory. The first reason for that is because everything is explicit, so you will use less infrastructure with SpringFu because you will declare explicitly things. So what you don't declare is not enabled. And on the Spring Boot side, on the regular Spring Boot side, it's all about clever defaults, but it can be as efficient as your own declaration, explicit declaration. Also, it depends, but functional bin registration tends to be a little bit faster. And generally, we use less infrastructure on the KoFu side. So yeah, we see a slightly faster startup, less memory usage. It's not the main goal. The goal is really to be explicit in terms of programming model, and we are also working on optimization for the regular Spring Boot that could allow to reach an efficiency close to JaFu with the annotation-based programming model. But yeah, it's nice to benefit from this improvement right now. And this year, there is a new thing is that a lot of people has joined the team. So thanks, Audrey, for joining the team for working on KoFu. That's a real pleasure. Thanks to François also, who contributed some code on the Kotlin side and who is working at Elastic. And we have Ariane Poutsma, who is a Spring Framework committer. Ariane has designed the web, Spring MVC and Webflux functional APIs, and is joining the team to work on JaFu and provide this expertise in terms of extensibility of the API. So let's now talk about native applications. So you will see more detail about native application in the other talk I gave with Andy Clement, but in a nutshell, GraalVM-native, which is what we use to compile a JVM application to a native executable, is a project that provides a compiler that allows to compile JVM bytecode to a native executable that does not require the JVM to be run. And that allows to create some lightweight container. And that's a pretty good fit with Kubernetes. So there is two main benefits in doing that. The first is instant startup. Instant startup is nice, not for your development experience, because native application take a lot of time to compile, but it's more to be able to have a scale to zero hosting. That means that you will not pay when your application is not used. That's a kind of serverless running model, but applied to any kind of application, including your regular web application. And if you are developing some back offices that are used 10% of the time, you are basically losing a lot of money, but also a lot of energy. So we are also talking about sustainability. So being able to only use a server when your application is effectively used, it's one of the big advantage of this instant startup capabilities that Audrey will show just a little bit after. The second point is reduced memory consumption. Reduced memory consumption, we have close to between 3x and 5x memory reduction. That's especially important for microservices. You know, when you split your previous monolith into 10 microservices, the consumption, the memory consumption of the JVM for each instance will be quite an issue. And being able to reduce very significantly the memory consumption tends to be super helpful when you are working with microservices. So why those new capabilities are exciting? It's not a free lunch, and basically JVM and native executables have different trade-offs. So while native executable shines on instant startup and low memory footprints, it provides slightly lower performances on latency and throughput, even if I guess that will improve, and even if the enterprise edition of GraalVM provides some features to improve that. In terms of maturity, we are not yet at the level of maturity of the JVM, obviously, but it's improved quite quickly. And the biggest difference is in terms of build. Usually, like the native compilation takes time, consume a lot of memory, and you will typically run this step in your CI. So native image compilation is not really something you will use to develop faster. It's more an optimization for container development that you will run on your CI/CD. So talking about efficiency, the gain is pretty huge. If you compare, so in these figures, we compare the famous pet clinic application that Audrey is going to show you. On the JVM, we are close to 400 megabytes of memory after usage. We have a startup time of 2.6 seconds, which is pretty fine. And so you see that you have a gain when you switch to KoFu. You are starting faster and consuming less memory, like I showed previously. But if you combine the advantages of using KoFu or JaFu and compiling to native application, you see that we have a pretty small footprint of 81 megabytes. So 81 megabytes is everything, I mean, not your OS, but everything about your application, your JVM, and it's starting almost instantly. So that's a pretty huge difference in terms of requirements, and that will translate as a lower cost and better sustainability of hosting your Spring Boot application.
Okay, so now let's move to the demo. So we're going to switch to IntelliJ, and let's put it in presenter view. That's going to be better. So we're going to declare we got the entire application already coded, and we're going to declare the configuration of our application. So first of all, we're going to declare a val called app, which is going to be a web application. So as you can see, as it is code, I got auto completion, which is very, very nice. Obviously, I also got suggestions. So here I'm going to start by declaring the web MVC part. So we're going to need a few things. We're going to use timeleaf for the front end. We're going to need a router, obviously, which will take some resources in parameters. So once again, you know, that's code. So I need to import the class path resource. Then we're going to need converters, because as Sébastien told you earlier, only what we declared is going to be installed. So if we don't declare converters, we won't have any. So we're going to use the string converters, and then we're going to use the resource one and the Jackson one. And for the Jackson one, I would like the output to be, you know, pretty indented. So I'm going to say indent output true. Okay, so that's for the web MVC part. We're going to use JDBC, so let's declare it. JDBC is going to need a schema and some data. Okay. Then we're going to add a message source for the internationalization. I'm sorry, that one is very hard for me, of the application. And here comes what is, to me, the most interesting part of specifying your configuration as a detail, is that you can compose your configuration. So here we took the option to split the configuration between each domain of the application. So you got an owner config file, you got a pet config file, etc. And we are going to declare them here. And so it will be unified as one single configuration at runtime. So we got a pet config, we got a vet config, a visit one, and we get what's missing, system. Yeah, exactly. So here we took this option, but you can definitely imagine, having one config for your development profile, one for your test environment, something like that. If we look at the owner config, so once again, it's code, so I can simply navigate through it, and that's very useful. So as you can see, it's a classic, if I can hide the menu, come on, yeah. So it's a very simple Kotlin file. So first we define a val which is called owner config, and which is going to contain all the configuration for the bin used in this domain. So here we get a repository, we get handler, and we get routes. So actually, this is not the usual way of declaring bin with the functional bin registration DSL. Usually what you would do to declare the owner handler, for example, is something like that. But the thing is that at the moment, we're having a little incompatibility for native image compilation. So we're going to use this syntax for the example. And obviously, as soon as it will be fixed, we will update the code source. So here, the interesting thing is that the reference method uses the function as a factory, and the function is then going to create a bin of the required type, which will be auto-wired. So now looking at the owner routes, so it's a simple function which declares the router configuration using the router function DSL. This one is, I think it's a really, really good one. It's extremely easy to read, easy to understand. So we're having string to declare our path. We can use string directly. We got request nesting. So here, by using the nest function, I'm telling explicitly that everything that is coming after owners will be handled in this function. And here I got a request predicate. So if I'm going to receive a request with the get method on the /new path, then I'm telling the owner handler to deal with it with the getOwnerCreationView method. But if this call is made with the post method, then I'm going to use the add-owner method. So quick look at the owner handler class, which is once again a very classic Kotlin class. So as you can see, every method are taking several requests as parameters and answering with a server response, once again using the router function DSL. And we simply responding still using the function with, for example, if everything went fine when saving a new owner, okay, then render this view with the new owner ID. A quick look at the owner class. So it's a data class because we're in Kotlin, so we take full advantage of the capabilities of the language. So all our fields are immutable except the first one, the ID one, which is declared new label by this question mark. There's a very simple reason why. It's because when you save a new owner, you don't have any ID to provide for him. Okay, so now let's go back to our application. We got all the configuration, but at some point we would like to run it, So we're going to declare a main method, and this is going to be very simple. Please pay attention. We're going to call the app val we declared previously and call the run method, and that's all. That's done. Okay, let's give it a try. Another very interesting aspect of declaring your configuration as code is that you can put breakpoint into it. So for example, let's say I would like to inspect this indent output value I declared. So I'm running. And here it is. I'm in the breakpoint. Nice. Okay, so the application is running. Let's have a look at it. So we're supposed to have something which is very familiar to us. Yeah, here it is. Our pet clinic with a list of owner. For each owner, obviously, we can see pets. We can add visit for the pet. We can list the veterinarian, etc. Nice. So back to code now. So first of all, we're going to stop this application running. And now let's see how we transform this into a native application. So we're going to have a look at the POM XML first. So this application is built with Maven. So here in the Spring Framework Boot plugin, you can see that we added some piece of configuration, which declares to the plugin how to build the native application by giving some environment variables. As you can guess, as we're going to build a lightweight container, we're going to have a Docker compose.yaml file, which is simply declaring a MySQL server service and the KoFu pet clinic service, which depends on this MySQL server. Logic. And then if we want to compile the image, we will run Neveu and Spring Boot build image. We're not going to run it right now because, as Sébastien told you previously, it does take a little bit of time to compile. So we're not going to show it. That would be interesting. But we're going to show you how fast it runs. So here I already got my MySQL server running for the clarity of the logs, and here it is. It's already started. Quite impressive, right? So let's go back to. Yeah, come on. I think that Zoom is messing a little bit with IntelliJ. And here it is. The application is running. We got our list of owners. We got our list of veterinarians, etc., etc. So that's all it takes to go to native application. So the entire code is available on GitHub. Feel free to clone it and test in local and send us feedback.
Thanks a lot, Audrey. And yeah, the sample could be found in the SpringFu samples. So you can go to the SpringFu repository and find the sources. So we are going to talk about a little bit the roadmap. So you can go to the SpringFu repository in the issues and click on the milestone. You will see the roadmap that we are going to detail a little bit today. So we are going to release very shortly SpringFu 0.4.1, which will bring Kotlin 1.4 support. And we will also upgrade the Docker utility that allow us to generate the documentation. And you will see a huge amount of progress in terms of clarity in how we document the KoFu DSL thanks to this upgrade. In November, we are going to upgrade to Spring Boot 2.4.0 because currently we are at the Spring Boot 2.4.0 M2 milestone. We are also going to add Spring Security support, and the good thing is that we are going to switch to native application and lightweight container by default, because with SpringFu and KoFu and JaFu DSLs, I think that's really a good fit for native application. By default, it has pretty great compatibility because this functional configuration model is natively a good fit with GraalVM-native compiler, which can analyze your application. So we are not talking about using it all the time because in terms of development, like Audrey said previously, the development cycle takes time. But once you have finished to develop your application, we plan to make it the default to use native applications. We also plan to use the latest and greatest version of Java because with Java, the current Java version, Java 11, we miss some features to really be great with this functional programming model. And I think with Java 17, the next LTS, we will be in a very good shape. We will have record, we will have a lot of improvements. So the strategy with JaFu is really to use Java, but to use the latest and greatest as the minimal version. So we plan to upgrade to it as soon as it will be supported by GraalVM-native, which should happen in the following months. Now, I would like to talk about our more long-term strategy because we have currently an issue on SpringFu. People that are using KoFu and JaFu are pretty happy, and we get a lot of great feedbacks. But the issue is more on our side. In terms of maintainability, we leverage some classes and some infrastructure of Spring Boot, but we duplicate some other ones. For example, the add configuration of Spring Boot are manually maintained on SpringFu side to create some functional variants. The DSL are manually maintained. We need to adapt to SpringFu evolution, and Spring Boot evolve pretty fast. So the strategy that we would like to have with Audrey and the other member of the team in the upcoming months is to use Spring Boot as a single source of truth and to create some kind of automated transformation that will, it will be not magical. We will not generate everything of KoFu and JaFu automatically, but at least generate a significant part of those DSL in a maintainable way and in an automated way. The first place when we want to do that is at the configuration side. So really the low-level infrastructure, not the part of the code that you will directly use as a public API, but the technical code that register the various bits. Here we compare the two versions, and don't be afraid, you won't have to write the version at the right. It's just underneath. At the left, you are declaring, like you do usually in your Spring Boot application, your configuration consisting of various bins with add bin methods in add configuration classes. And that's very nice to be read by a human, but for a compiler can't automatically understand what we will do with this code. There is too much abstraction. The example at the right, it's based on functional configuration, functional bin registration. It's a functional interface that we need to implement, application context initializer, that will basically be a consumer of generic application context. And here we can call application context.register bin, and you provide a lambda to provide a factory that Spring will use to create these bins later. And this way of declaring bins with lambda is natively understandable by the GraalVM-native compiler, for example. So that's a pretty good fit if we want to use this variant. But we don't want to write this code manually because that's painful and because that would be a duplicated information. So in Spring Boot 0.6, we plan to do automatic generation and functional configuration. That way, the configuration in Spring Boot, so the Spring Boot auto-configure module, will be automatically translated into a functional variant. And the good thing is that the work is already mostly done thanks to Dave Sayer and to Andy Clement. So we have been working for 1 year. Maybe you don't know this project, but have a look. It's pretty amazing. Spring Init is a project that's it's experimental, but its goal is to convert automatically, usually at build time, an annotation-based configuration towards the functional variant. And currently, we generate the whole Spring Boot auto configuration in a functional way, and it works for most use cases. So we are going to leverage that in SpringFu 0.6 to do that automatically. The other step is the step after. So, okay, we have reduced the duplication for the configuration, but what about the DSLs? I mean, with Audrey and the other contributors, we keep seeing people asking, could you add some support for that? And we don't always have the time, and it's also hard to keep up with the pace of Spring Boot, who keep adding features. So here the strategy would be to automatically generate the DSL, JaFu and KoFu, based on the properties class of Spring Boot. Those properties class contain most of the information that we need. We know that for R2DBC, for example, here we have the commands that will allow us to generate the documentation. We have the name, we have the type, and so we think we need to verify that, but we think that it could be possible to generate automatically the KoFu and the JaFu DSL based on those information and based on some bits that we will define on the SpringFu side. So this is our goal, to really generate automatically those DSL. So this API generation is a big challenge, but with high rewards. better quality, because when we do this manual conversion, we do mistake because we are humans. In terms of maintainability, we will avoid to have some duplication compared to what Spring Boot does. So that's a clear separation. SpringFu is responsible for the DSLs. Spring Boot is responsible for the engine, for the configuration, for everything else. And maybe it could open the door later to those DSLs to be integrated in Spring Boot, who knows? And in terms of scope, the compatibility, the support that we have will be much wider, because that opens the door potentially to support all what Spring Boot currently supports in a functional way. So thanks for seeing this talk. I share here the address of the GitHub repository. We are going to post some blog posts to keep you informed about the progresses, and you can follow Audrey and me on Twitter if you want to have fresh news. Now we are going to switch to the Q&A session. So we are going to see you there. So feel free to ask your question. I think somebody will share the link on Slack, and see you there. Thanks.
Thank you.
Well, thank you, folks. That was a wonderful talk. I'm sitting there thinking, okay, I'm writing all this Java. I could write it in JaFu or KoFu. But, you know, it's awesome. Thank you for spending the time to explain this to us. It was really good to go in kind of the deep dive of how much time it can, or sorry, how many resources it could save in the various ways. Again, folks, if you want to ask questions, go to the Slack room for this talk. And with that, you can click the link and join them on a Zoom session and ask questions away. Thank you so much, folks. Our next talk is at 5:05 today at Eastern Daylight Time. We'll see y'all in a little bit.